In this video, I'd like to give you a little background on simulation-based statistics and why something like StatKey can be very important in an introductory course. StatKey is a web-based piece of software that is provided by the authors of our textbook, and we just simply log in at the lock5stat.com website. What we're going to look at today is just this idea of if it was all theoretically based, you would see things like this, which we're going to see later in our course, to explain a one sample proportion sampling distribution. So what that would mean is suppose that at Penn State, we need to do some marketing or some stocking of apparel or some decisions about ticketing for the sports team. And we want to get a good representation of what the true proportion of all Penn State main campus students that are interested in sports is as a proportion. So how do you do something like that when there's that many students? Well, you randomly sample, and that's a technique we'll talk about. You randomly sample, and you get a sample proportion. For example, maybe we randomly sample correctly 200 people, and we ask them, you know, do you favor going to a sports event on campus or following a sporting event on campus? Say 70 of them say yes. So 70 out of 200 is 35%, 0.35. If we randomly sampled again 200 people, we would likely not get 70 exactly. Right? Next time we may see 74 people out of 200. If we randomly sample again, we might see 60 out of 200. If we continue to do that in the long run, if we plotted those points, we would get something that would be a normal distribution, approximately, the bell shape that many of you are used to. And it would be able to allow us to get a confidence interval then, a range of values where we think the true proportion of Penn State students that are interested in sports lies. And then from there, we can make decisions about marketing, ticketing, etc. So what I'm showing you on the screen here is what traditionally students would see in a stats course that's been offered for many years in a typical textbook. If you read down through here, it's pretty complicated. It's very abstract. It's hard for students to understand exactly what's going on. And again, we'll do that later in the course after we simulate. Using StatKey, we could simulate the situation I just gave you and hopefully help students understand with very little mathematics early in the course what the concept is about. They can visualize it. And then later in the course, when we bring back the theoretical part of this, it'll make a lot more sense to students. And this is research support. So here we go. I'm going to use what they call the simulation for the confidence interval per proportion. And it does come, StatKey, that does come with populated data sets that you'll see in our textbook. But it also gives you the option to enter your own values. So for example, in this case, I am going to edit the data and say that I got 70 people out of 200 who stated that they indeed were interested in sports on campus. And you can see that that's over here to the right. 70 out of 200 is 35%. Again, if I sample again, 200 people randomly, I'm not going to get 35% again. In all likelihood, I'm going to get some variation. That's going to allow me to actually plot this each time. Each time I take a sample of 200, I'll plot the proportion. I want to show you some of that now. So if I generate one sample, so what's going to go on here is I'm taking my original group, and now I'm going back in and selecting from them 200 times with replication. So I'll pick somebody randomly out of that 200 and see what they said, yes or no in favor of sports. They go back into the hat, right, and shook up, randomly sample again. And I do that for 200 times. When that happens, it looks like this. So I'm going to generate one sample of 200 people from those original 200. This time I got 75 out of 200, which is 37.5%. And you can see that plotted down here on the graph. I'm going to do it again. This time I got 74, and you can see that plotted down below. The triangle that you see now is the average of those two samples of 200 that I took. Do it again. This time I got 75. 75. 59 out of 200, right? Only 34.5%. 58, only 29%, way out here. And this updates the average of this proportion every time. And you can continue to do that one at a time and see what's going on as far as the samples that are falling. But we can actually expedite this and see if we did this 1,000 more times. So I'm picking 200, recording the S's out of 200, and then doing it again for a total of 1,000 times. You start to get a distribution that looks very familiar to most people called the normal distribution. And if I do that, we usually ask you to do it about 5,000 times so that we know that we're settling down nicely on this. This normal distribution is called the sampling distribution of the proportion. And now you can tell that indeed you can make some inference from this later in the course, because if you notice, originally we had 35% net sample. As you sampled 5,006 times 200 people, it ended up giving us a sample of 0.35. That is really good because 35% in the sample predicted the population value, the original value that we had, not the population, but the original value we had right on. And that's going to be a powerful tool later in the course. The other thing here is the standard error. This is a measure of how much spread there is, how much variation in those proportions I took, and that's a measure of 0.033. And then ultimately the culminating activity of this will be saying, hey, I would like to see where that interval falls that I talked about at the beginning of this video of the estimate of the true proportion of Penn State students who have some interest in sports. So I can click on this two-tailed button and say, with 95% certainty, I believe between 28.8% and 41.7% of students have some kind of tie or interest in Penn State athletics. And you can make, statements about that, marketing decisions, ticketing decisions. But that should be helpful, this visualization as you work through it. And we give you plenty of notes and support. That should be helpful when we get to the actual theory of the course. Just jumping into the theoretical part can be quite challenging for students. So that's a brief introduction to StatKey and why the visualization